Hello. Today I thought I'll teach you something new, some new terminologies and some new notations. But conveniently for us in math, when you have to learn anything new, it's usually motivated by some problem at hand we already have that we weren't able to solve completely with all the tricks we knew. So the problem at hand now is there are two equations x plus 2y equal to 8 and x plus 2y equal to 1. We saw this problem a while back in linear equations with two variables playlist, I think, and we graphed the equation then, and we found out that the lines were parallel and they didn't have any solution because there are no values of x and y that simultaneously satisfy both the equation. Or another way of putting it would be the lines were parallel, so they did not intersect anywhere, and that common point we were unable to find. So there no solutions existed. But during the explanation of this, we left out a crucial point for future, and that was the explanation for why these lines are actually parallel. Uh, we did something in the form of the coefficient of x and y, and that was a huge formula, and I don't like to remember formulas. So hopefully in this two video series, uh, we'll introduce some characteristics of a line that we might not have seen before, and for introducing that, I thought I might as well introduce functions to you. So you bear with me till this small deviation you might think, but everything will come together ultimately. So what are functions? I wanted to introduce this concept here. In the second video, we'll obviously see why the lines are parallel and why the lines actually look the way they look on the graph. We just plotted and we did it mechanically, but this might give you more of an insight. So functions can be thought of as a computer that takes in inputs and gives you outputs. That's what basic computers do, right? So it takes in some input and gives you an output, but here I am specifying that functions have to give me a single output for every single input. What I mean by that is, if I input, say, the inputs are real numbers, it's here. So the inputs can be any real number. If I am inputting, say, square root of 2, I shouldn't get the output as 4 and 5 and root 2 and 1.7 all at the same time. I shouldn't get this, shouldn't happen in my case. There should be just a single output, right? So this is the way I'm defining what functions are. I know this is not very rigorous, and rigorous definitions we'll see in the future, but for our purpose now, this is more than enough. So say that I am inputting some x as input. X can signify all inputs we are allowed to have. The function would do some processing with x. It will do something with x and it will give me an output, and I can call that output f of x. So this is f, and this function I am calling it as the function f. So what this notation means is x has been operated upon by the function f. This does not in any way mean f multiplied by x. It's just a fancy notation for output of the function. So how will these actually look like? This might be very abstract to you, but how will these functions look like? Say that I have a green function that inputs any x, and I ask it to take away 2 from all the inputs and give me an output. So the way I have designed the function, taking away 2 function, right? The way that I'm specifying the procedure, there has to be a unique output for every input, and this qualifies as a function for us. If that is ambiguous, if the process I'm giving is ambiguous, it might not be functions. It might not be a function, and there are several non-functions out there we'll maybe see about in the future videos. So taking away 2, how would that how would that work? Say I have inputs and outputs. If I'm inputting 5, my output would be taking away 2 from 5, 3. So if I'm inputting 5, 3 would come out. If I'm inputting 3, 1 would come out, right? And you get the idea. If I'm inputting 0, negative 2 would come out. For negative 2, negative 4 would come out, and etc. So this is one function we could have, or maybe we could have a bit of a fancier function. Say I'm calling it the square root function. I'll call it the square root of x function, where I'm inputting x, and the output I get is the square root of that number, so of x. So I can write the equation for the function as f of x is equal to square root of x, because this is all that the function does, right? You give it an x, it processes it and gives you the square root of x as an output. I'll clear up the mess I made. And how will this look like? If you're wondering, we are writing all the functions now in the form of a table maybe, but there are better ways of representing a function. You could have an axis. We have seen this idea before, but I'll go over it again. We could have an axis for input and an axis for output, so that we could represent the function as a graph, as just a couple of points in the coordinate axis. So this x can be the input axis and y can be the output axis. So I am calling this axis f of x, which is actually equal to y in our case. Y axis signifies the outputs of the function f of x. So how would square root of x look like? So again, drawing the graph from the techniques we know, we substitute in a few values of x, and we are trying to find what's the output in those values, and then we'll plot it as coordinates. So 0 would output 0, because the square root of x is the square root of 0 is 0. Square root of 1 is 1. Square root of 2 is root 2. Square root of 4 is 2. Square root of 25 is 5, and so on and so forth. So if I had to plot this function, how would it look? 0 comma 0 would be a point. It's this point. Input value 0 and output value 0. 1 comma 1 would be a point. My graph won't be accurate, of course, but 2 comma root 2 would be a point, and root 2 would be something short of 2 and greater than 1. So the increase in x would be 2, but y wouldn't increase as much, so I'm plotting it here somewhere. 4 would output 2, so this is maybe 1, this is 4 would output 2. There will be 25 somewhere here, and that the output will be 5 maybe. So the function would look something like this. So obviously you don't need to memorize these graphs and all, but I'm just showing you what functions could there be. Now the important thing for us, the important takeaway for us would be the functions are like computers. They take inputs and outputs. Doesn't this graph suggest that there are these lines can be looked upon as functions? So if we have this equation, say x plus 2y, I can use a new board now. Say that x plus 2y equal to 8, and I can rewrite this same equation as 2y is equal to negative x plus 8, which in turn becomes y is equal to, I'm dividing both sides by 2 now, so negative 1 over 2 x plus 4, 8 over 2. So now, can you not look at this as a green function which does the following? It takes a value x, it divides it by -2, so it does this, and then it adds 4 to it. So these are a couple of steps actually. So it adds 4 to it, and then it gives you the output as f of x, which is, again, we have written it as y, but that's the output of the function. So can I not write this whole thing is equal to f of x, maybe, to write this as a function? So this was the point of the video. You can actually look at lines as functions, and you can plot them in the graph, and the plot will obviously be the same plot, this plot. And for the other line, the function would be something like this. I'll still use the same color. X plus 2y equal to 1, and this would mean y is equal to, I'm skipping a couple of steps, but I think you get the idea, plus 1 over 2. So here I have asked a function to divide it by -2, divide the input value by -2 first, but add just 1 by 2 to it rather than 4. So these are two functions we have. I'll call this maybe g of x. So we have two functions, f of x and g of x. One function is this green one we have represented, and the other one is this one. And in the next video we'll see what are the characteristics of linear functions, what are the slope of a line maybe, and the reason why they are parallel, because the slopes are ultimately equal. The slope, I mean by what I mean by the slope is just the inclination of the line. It's nothing too much. So we'll define all this rigorously in our next video. So I think I have covered everything about functions we need to know. I hope you understood. Thank you.